So welcome. Thanks for coming to the session. This is the exam prep for the exam 7532, which is the developer exam, so developing Microsoft Azure solutions. So my name is Cale Teeter. I'm a MCS consultant, but I work in the Azure PaaS COE for Microsoft. So typically I travel around to customers, helping them either create applications on Azure, mostly PaaS, but some IaaS, and then also do migration work for them as well, bringing their legacy workloads to Azure. And I give this session internally, and so we brought it to Ignite to actually share with you guys. So real quick, just one slide on the certification. If you don't understand the Azure certification exams that exist, 532 is a developer exam that we're going to go over today. 533 is the infrastructure exam. So if you're an IT pro, that one's more targeted towards IT pros. And then the 534 is the architecture exam. That's more around designing and things of that nature, not necessarily the details. So these first two, the 533 and 32, are really in the details for each one of those, specifically on developer to the development aspects that you run into in Azure. IT Pro would be more around the VM sizes and all the different things that you run into with Azure with that. There's a bit.ly link here to the certification app, so you can always go up to the Microsoft certification site, but we also have a Windows 8 application that you can download from the store, and it gives you all the tracks and all the certifications. So from skills measured, if you go up to the certification site, and this is what I highly recommend to people that are taking exams, especially in the Azure track, there's a little grid. So once you click on 532, 33, or 34, at the bottom you'll see the skills measured, and each one of these expand. But these are the areas that the test is going to be focused on. So these are the areas you need to know really well if you're going to pass the test. So I just put it in here, just make sure you take a look at it. But we're going to get through each one of these in detail here today. And that kind of alludes into this. So the session objectives here is to basically look at the first three blocks there are basically the deployment targets that we would have in Azure if we're going to host an application or deploy an application to Azure. The first one being websites. The exam, obviously, because of Azure evolves really quickly. You guys may have heard of web apps and some of the app service stuff that we just announced recently. The exam has websites on. That's what we had at the point when we made the exam, so that's why it's in here. But you can basically substitute website and web app, same model. We also have virtual machines, so we'll talk about those a little bit. Not from an IT pro perspective, but from a perspective of what you need to know as a developer if you're going to leverage virtual machines. What are the details that you need to know about that, specifically to match that grid I just showed you from the skills measured. Then we'll move on and talk about cloud services, which is primarily PaaS. So that would be the web and worker roles, the traditional. Since we've had Azure, that was the first foray into the public cloud. We had the cloud services. We also use cloud services in IaaS, but we'll talk about the PaaS side of it mostly here. And then the last two that we'll talk about are storage and network. They don't fit into the same place. Storage kind of overlays everything. So Azure Storage is used for any workload that we're going to run up there. Certainly those three that we have listed there, beyond. And then also we'll talk about networks and some of the management and service bus things that kind of don't fit in another category, kind of integration stuff. So the key takeaways, obviously, are to get certified on Azure. I recommend, if you take this course, if you have some development background and a little exposure to Azure, take the test. It's a great opportunity here. You have the 50% off, plus you can take it second shot for free. So if you have some experience, and this is kind of just a recap for you, go take the test, get certified. And then also, it's beyond that, though, for me. The certifications are great because you can, check that box, you have it on your resume, you can show it to your boss or prospective employer. But also being proficient with Azure is like the big thing, so just going through and understanding what the motions are, but understanding how do I build apps up there, because that's really what's important. The certification's great because it shows your creds, but it's important to be proficient. The other thing is, so when we start out here, I just want to mention this. We basically have two portals up in Azure right now, management portals. And I call it the tale of two portals. But essentially on the left side, we have the existing portal that most of our functionality grew out of. And then we have our preview portal, which is the portal.azure. And I put the links on here for you. The only reason I mention it here is because I'm going to show you screenshots of some of this stuff. Some of the stuff's in the old portal, which would be the left side, and some of the stuff's in the preview portal. And so just know that there's not feature parity between these two. Some things can only be done in the new and the old, vice versa. So we'll start out with Azure Websites. So Azure Websites, we're going to cover 6 basic areas here. We're going to talk a little bit about deployment. What are the options we have when we're deploying an application to Azure Websites? What kind of things come along with that, and why would we pick one over another? Those are the types of questions you're going to see on the exam. Configuration is another high item. So basically, we're going to talk about some of the application settings files and how do those fit into the framework that Azure has provided for us. So we have configuration we have in our application, but we also have some stuff up in Azure that we can leverage, and how do those kind of work together? So we'll talk about that. We'll talk about diagnostics. From a diagnostics, it's more around the logging sense and the operations logs that we have in Azure to see what happened and when things went wrong, or even if they didn't go wrong, what actually happened up there, some of the actions. And then we'll talk about some of the bottom row. So the web jobs is a back-end processing model that we can use with websites. So in the traditional sense, we had the cloud services. We had these worker roles, which were essentially a Windows service that runs in Azure. Web jobs are kind of the counterpart to that, but only run in website context. So we'll talk about the details of those. We'll talk about scaling and resiliency as well, the hosting model that we have with websites and how that's important. And again, I'll try to put these in the context of the test so we can focus on those areas. So from a deployment perspective with websites, we have 3 fundamental ways to deploy our application that we've written up to an Azure website. So we have this thing called Web Deploy, which is built into Visual Studio. We can also run it from a command line, but essentially what this is, if we're doing a publish straight out of our Visual Studio client, we can actually use Web Deploy to do that. It will set up and basically take your credentials. So you'll sign in with your Azure AD account that you use for your portal access. And this thing will go ahead and set up a management cert that it's going to use to do the deployment for you. We'll talk a little bit about Visual Studio Online. So Visual Studio Online and Visual Studio in general, that's more around the continuous integration standpoint. So does anybody not familiar with continuous integration? It's okay if you're not, but okay. Okay, so continuous integration is really just about saying we have this source code repository that we pushed our code to, and we want it to automatically trigger a build and maybe a deployment automatically for us whenever that happens. So if somebody checks new code in, we could set up either a gated check-in where somebody has to approve it and then it gets deployed, or we can do an automatic deployment that just says, go ahead and put it out there. So typically for like a dev or a staging type instance, this is good because you can just keep pushing things up there. It depends on the customer and depends on the workload that you're doing. Sometimes people don't want builds to break just because somebody pushed code. Well, that's what the continuous integration is about. Sorry, question?
Is that one made by the webhooks and the VSO portal?
Yeah, so the question was, is that in the VSO portal? So yeah, it's a separate service. It's called Visual Studio Online. So it's part of your MSDN account. If you have an MSDN account, you have access to this. You can go up and create essentially a portal there. And then you can set up a relationship. We'll talk about that a little bit here, but you can set up a relationship between Azure and your VSO account so that it can do the automated deployments for you. But yeah, good question. And then on the file side, it's basic file management. So we can actually do an FTP build too. So we can say if we have an FTP endpoint that's established when we have our Azure website, we can also use that to target it. So test questions that you typically see around these kind of things are, look for the keywords, right? So if there's going to be somewhere where they say, I want to do automated deployments, I want to do automated builds and have these things automatically deploy hands off, no manual intervention, you're going to be looking for VSO and continuous integration. If you see things mentioning, they want to use some other system, maybe not VSO, maybe they have a different source control system or a different build server, and they're looking for ways to automate their builds, you're going to be looking more towards a file-based system because it doesn't have that same integration level. I took a screenshot here from the preview portal, which basically shows when you click on a website that you have deployed, there's a bunch of telemetry and things that are in here, all your settings, but I circled this area around deployment. And if you click on this continuous deployment area, that's where you would configure, and it's actually shown in a couple other slides here later, where you actually enter your credentials for VSO, and that's where that relationship gets established between your VSO portal and this website that we have running here. The other thing to mention is deployment slots. You see it mentioned here, it shows 0 on the slide. I didn't have anything deployed there. So with websites, it's a little bit different from our cloud service model. So to back up a second, deployment slots are what we can deploy our application to. So we can have multiple up there. And then we tie our endpoint that the public is going to see to one of those. So by default, if we just had one deployment slot, it's going to point to our public interface. That's what people see when they come to whatever URL we have exposed here. But we could also set up other deployment slots and say, let's make a dev one, let's make a staging one. And when you're in the websites model, it's a little bit different from cloud service. We can have 5 of these, and they're user-defined. So you can basically establish the name yourself, and then you maintain it. And the idea is basically if we had like a staging slot we could push code to, it creates a separate URL. So if your main URL was ignite.microsoft.com, you could create a staging.ignite.microsoft.com, and then you could test it as a developer. The outside world wouldn't see it. And then when you're ready, you can do what's called a switch, which will basically switch the load balancer to point to the other one. So it gives you that kind of instant deployment that you're looking for this kind of thing. So again, test questions around the customer has a need. Sorry, you got a question?
Just a quick question. When it deploys that to a slot if it's staging, how does it know not to write to your production database?
So the question was, if we have a separate slot that's like a staging slot, and it's pointed to the database. So there are separate instances of your application. So the connection string, obviously, you want to make sure that you maintain that correctly. Yeah. We can actually use some of the other things with settings here. I'll show you in a second to control your configuration settings so that doesn't happen. And that leads right into here. So that was a perfect segue. I didn't stage that. That's from him. So on the configuration side, we have this unique capability with Azure where typically when we have a web application workload that we're going to deploy, we have a web config along with that if it's an ASP.NET app. And so in that web config, we usually have connection strings and key value pairs that we're going to deploy. We also have this notion of what's called app settings up inside Azure for our website. And it looks very similar. So it's key value pairs as well. And what happens is at runtime, we're actually going to do a merge. So if we define something in the web config, let's say our developers are doing that, they're pointing to a dev database, we can go up into the app settings as, let's say, an administrator or an ops guy and maintain the connection string in the Azure portal. When they deploy code up there, it's going to see, oh, I have an app setting up here too. That thing overrides whatever was in the web config. Go ahead. Sure.
About config transforms, or is this a soft version of config transforms?
Yeah, so the question was, is this comparable to kind of the transform mechanism that we have in Visual Studio? So this would be post that, but yeah, it's doing a similar operation to what the transforms are doing, but only in the cloud. So the key is, if you have other things that you need to add to your config, that maybe they're secret items, a payment gateway or something like that, where you have a key that you don't want to share with your developers because then it gives them the keys to your payment gateway. You could log into the portal and actually add that, and they might not even have it in their web config. So if it doesn't exist in the web config, it'll just add it at runtime. If it exists, this one will override whatever's in the web config. So a good way to kind of bulletproof when you're doing your things and also keep things secure and maybe out of the hands of the developer in some cases. Sure, we got a question?
Does that require the explicit use of the Cloud Configuration Manager, or is that a sort of built-in override?
Yeah, so the question was, does it require the use of the Cloud Configuration Manager, which is a class that we have inside the .NET extension for the SDK for Azure, in order to access those connection strings? It doesn't matter from that point. It's going to read whatever the app settings that actually get deployed with. And so if there's something defined in the app settings, it's going to look like it came from your web config. So you can use the Cloud Configuration Manager just as well. No problem. And here's the configuration screen. So basically, again, I'm just showing you where it's at, just so you can get acclimated, because you can see there's tons of settings in here. But if we go into the app settings area, you can see over here on the side the app settings, and that's where we would enter those key value pairs to do your overrides. So I put in these. I sprinkled some of these. I haven't done this in the past, but it was mentioned that maybe some people haven't even taken these exams before. So I'm just trying to give you a sense for like some of the questions and how they might be formatted. So I have a couple different formats here, but this is one that's typical. So you see something like customer is interested in leveraging an Azure website to deploy a public-facing website. And it's for an e-commerce application to its clients. And the site integrates with a payment gateway, like I mentioned before, via web service call. And so they want to store these configuration values in the application configuration, but they don't want to share them with the developer. Kind of the canonical use case that I just gave you a minute ago. So how would we achieve this? And obviously, it's just one of these, I'm sure because we've already discussed it, but if everybody could point out, you could add it to the app settings in the Azure portal. It's out of the hands of the developer, and you have total control of it in that case. The last thing here is we have on our diagnostics. So from a diagnostic standpoint, we have a lot of things that we can turn on in Azure websites. Great test question that you might be approached with is this extended diagnostics and logging turned on by default? And it's not. Reason being, when we're running in the cloud, these things tend to get large. We tend to build up lots and lots of logs over what we're doing, especially if we turn up the verbosity of these. So by default, these will be disabled or turned off. If you're looking to achieve some sort of diagnostics or you're having some issues, you're going to have to come into this area of the portal and actually enable these. Now there's multiple things, so we can see the site diagnostics on the left side there, where we basically can turn on from our web server or from our detailed error messages, also our request tracking if we're using that feature. And then on the top side there, under the application diagnostics, we can turn on stuff to log it. Actually, the file system access, we can do event logs from Windows, so we can dump all that stuff out there. Now, the interesting thing is this can generate these things and drop them out to your site, and there's FTP links there at the top, so you could download these log files or set up some sort of custom orchestration to pull those down. So a great test question would be if somebody had an existing management system or monitoring system, and they're looking to kind of grab the logs out of Azure, they don't really want to deploy anything, is there any way for them to get access to those logs? And you're going to be looking for something simple like FTP solution in that case to grab those logs. We also have this notion on the right side of these streaming logs. So the streaming logs are really interesting. So basically this allows you to, once you've enabled some of these diagnostics, you can come into the portal and actually fire up a little console window and see the active ones, see the active logs being streamed. So if you said, okay, we're having this issue every time we get a request, maybe it's on your staging site. So obviously if you put it on production, you're going to see tons of requests coming through here. Probably not a good idea. But for a dev or staging instance, you could enable this. You could come in here and see the logs real time. As you're making the requests, you could click through the site and see those things show up there. Sure.
Default storage location is Azure Storage or something like that?
Default. So the question was, is the default storage location Azure Storage? Yeah, it gets stored along with your website. So it'll come along with that, with the quota that you have for that. The other thing we mentioned before was about web jobs. So we have this notion of being able to run a background process with Azure websites. We have other ways to do that with Azure, things called Azure Automation, which is a PaaS type solution. This one goes along with and pairs with Azure websites. Key thing to remember is you have to have a website deployed and even to use web jobs. You can't just fire up a web job. We have to have a website associated with it. And the idea was if we have these jobs like, again, maybe we're scraping log files or something like that and we want to send them somewhere else automated. Maybe we want to do some sort of processing as people are clicking on things in the site. So if somebody said they clicked on a site, maybe it drops something into a queue up there, a storage queue, a message that says, hey, they did this certain operation. Maybe we want to send them an email at a later date or something like that. We can actually wire up a job to do that so that it can read from that queue and do those things. And that's where the web job SDK comes in. So the SDK actually allows you to write scripts, and you can actually target the service management API really easily. So if you want to write stuff to blob storage or read stuff from blob storage as part of your job, you can do that with the Web Jobs SDK. So these jobs can be two ways. They can be on-demand or scheduled. On-demand would be something that's infrequently run. It's a manual operation, so there's no schedule or anything tied to it. Obviously, a scheduled would be something like Task Scheduler, where we set up a time that we want this thing to run. We can run them in it's called continuous mode if we're doing the schedule, because it'll basically run it, and then we can have it run again at a certain time, so we can set up a schedule. Pretty simple stuff. So there's two different interfaces for this. I showed the old and the new, and the reason I showed that is because the preview portal currently doesn't allow you, if you look at that second box, it says how to run, where it says continuous right now. There's no scheduled option there right now, so here's a place where the portals are kind of different. So if you're looking for that scheduled option when you're trying this out or testing it out, you're going to want to use the old portal, and you can do the how to run. And this drop-down will actually show you where you can set up a schedule. Just something to point out. So from a scaling and hosting perspective, we have a lot of different models here to do this. This stuff is relatively new. I think within the last year and a half is when this stuff really started to come into fruition. Looks a little complicated, but it's for a reason. So basically, if we start in the middle and work our way out, so if we look at the line with production sites here, we have a bunch of globes there. They're representing websites. So if we had a bunch of production websites in here, we can wrap them in what's called a web hosting plan. Now, the web hosting plan is essentially a container that allows you to basically spec out the size of the VM underneath this thing, or how much horsepower does it need. So for production sites, maybe we're running at a SKU like an S3 or something because it has more CPU, more memory available. We could set up one for staging sites, and then maybe we can make that one a little bit lower, or vice versa. So essentially what we can do is allows consistency with your site. As you're provisioning new sites, you can have your production container there that tells it, okay, this is what kind of SKU I usually use without using S3, and you can tell your ops guys or whoever does your deployment, hey, make sure you just target this for production and this for staging. Everything's taken care of then for them as far as machine size that it's going to use. So that kind of handles the web hosting plan side of it. We also have this resource group. So this resource group's relatively new. And again, what it is another level of a container. This is not probably a great representation here, but usually what people use it for is we would wrap maybe the production sites in a resource group. And then what we can do is tie costing and usage to that. So if we had business units at a business and each one of those have chargebacks, or we want to know how much usage each one of them is using, we can put them in a resource group, and then we can target that resource group for those kind of reporting features. Some of the far-reaching stuff with that now would be to target those resource groups with other things like scripts. The cool thing about that is it does tag it in the API. So if you were to write a script and say, I need to do something to my production sites, I need to do this special operation, you write a script to do it, you could actually have that script target the resource group, and it'll just walk each one of those things that are inside of there and do that operation. So great feature for that. Again, if you're seeing these things on the tests, the things you want to think about is the web hosting plan. Remember that it's going to control like what level of VM is running underneath that thing, what kind of horsepower is tied to whatever sites that are inside of there. So if you see a question around that, you're going to be looking at web hosting plan. Resource groups are really around providing, chargeback billing information and being able to target a group of servers with something. And with that, we will pop over to virtual machines. So with virtual machines, different type of workload. It's typically called IaaS, or infrastructure as a service. And it is on the exam, even though it seems a little less devy. It's more about the infrastructure behind it. But we'll point out a couple things that are a little bit development around it. Might have to help those IT pros out with. So we have basically 7 different things we're going to talk about here. We have the deployment for the VM workloads, how we're going to do deployment, what that looks like. We'll talk about imaging and how we control our images. What OS is running up there, what software is installed on it, how do we get those to be consistent for our workloads. As developers, we are always tasked with having our whole stack of whatever we need. We need SQL Server, we need these frameworks installed, all these different configuration items on the server. And that's where the configuration management and the images kind of go hand in hand. We'll talk a little bit about the virtual network, the VM networking, and how that applies to us. From a scaling perspective, we'll talk a little bit about how we scale these because they're slightly different from the PaaS model. A little bit more hands-on when you're doing these kind of things. We'll talk about the storage model and some of the management. So when we start talking about the deployment, we actually have, again, another little eye chart here, but just to walk you through what we have here, if we start at the top rectangle there, we essentially have a virtual machine. If we start in the middle, that little monitor is our virtual machine, and it's wrapped in a cloud service. So I mentioned before that we have cloud services in PaaS, and we have cloud services in VMs. And this is like a common place where people get confused. So they'll say, wait a second, I thought a cloud service had to do with a deployment target or something like that. Why is my VM in it? And really, it's because that's the way what the platform needs. We can't just run a VM up in Azure. We have to have it wrapped in sort of a container. And the Fabric controller is actually making calls into that. And that's why we need that cloud service wrapped around there. If you go to spin up a VM through the portal, it's going to force you to do this. If you do it through PowerShell, it's going to force you. So it's good to go ahead and provision those ahead of time. We also have a VNet. Key question that you might get asked is, so I fired up a bunch of VMs, or customers started a bunch of VMs, and they didn't set up a VNet. And they're in the same cloud service, so everything's cool. They'll communicate. So if VMs are in the same cloud service, they can communicate by default, no problem. They'll be able to see each other. If you start deploying them to separate cloud services, then you'll start to run into issues. They can't communicate. And so now the customer says, I figured out now I need a virtual network. So can I just like spin up a virtual network and put my VMs in it? And the answer is no. So we have to build the virtual network, and then we'll have to tear down our VM and bring it back up inside the virtual network. So there will be downtime. So if you saw a question that says, is there downtime to move a VM into a virtual network? Yes, there is. We can't do that on the fly. Bottom is about storage. So VMs are dependent heavily on storage. So basically, we have a couple different types of storage that we have here. We'll start at the right side. We have our OS disk. Every VM has to have an OS disk. It's baked into the portal, and it's 127 gig by default. That might be a statistical question that you might see. So the biggest size you can have right now are 127 gig, and that's what the OS disk will be. Now, there's sparse disks, so you won't be paying for that. You'll be paying for whatever it uses, 20 gig, 30 gig, whatever. The data disks are additional, so they're not there by default. If we set up a script to go ahead and provision them, which we'll talk about with some of our advanced configuration deployment stuff, you can have those automatically created, or you can go up into the portal or through PowerShell and create those data disks. Again, those can be up to 127 gig, no, those are actually 1 terabyte. I'm sorry about that. Those are 1 terabyte. And then we also have this notion of what's an image here, and we'll talk about what that means. But basically, we can capture an image of whatever our virtual machine is up there so that we can use it to clone or build other VMs that we have up in Azure. And then the whole thing's wrapped in a storage account. So again, when you're setting these kind of things up, the thing you want to think about is all the containers that are involved here. Get those things set up first, and then start putting your VMs in. Similar to the web hosting plan. Get your web hosting plan going, get your storage accounts set up, and then start putting your workloads in it. Makes life a lot easier. So from a deployment perspective, the things you need to focus on, especially for the test, are we have a couple different ways to do our deployments. We can do, and this is basically deploying the actual VM. So if we had our application installed on our VM, it'll automatically get deployed for us. If we don't, this is going to deploy like our operating system, whatever required software we have on there. So we have our marketplace on the left side there that basically has pre-configured VMs. Key point to remember, if a customer, or if you saw a question that said, the customer has their own license for, let's say, SQL Server workload. They already have a license. They're running it on-prem. They want to start using it in the cloud. So if they're going to do that, you're not going to use the marketplace image, because the marketplace image is designed to say, we already configured SQL Server for you. It's already running here. And we're going to charge you for the VM plus the cost of the SQL Server license, amortized over time. So those things are going to be slightly more expensive than running a raw VM and putting your own license on there and installing SQL yourself. So in that model, if the customer was bringing his own, you would want to build your own VM, maybe create an image or use DSC or one of these tools to actually install your software for you. PowerShell is another way to do it. So PowerShell, we can actually do some pretty advanced scripting stuff. I showed one here where we're actually setting up a config. We actually specify the size and what image name. And if you notice here, we actually have the image name actually running another PowerShell command to actually go get it from Azure. So that's actually reaching out into the Azure Data Center and saying, give me the VM that's at index 4. I had already looked it up beforehand. That's a SQL Server image. And then we can get the image name. We can add our provisioning config with our admin name and password. And then we'll create our VM from there, and you're off to the races. So from an image management perspective, we have ways to basically leverage our inbuilt stuff inside of 2008 and 2012 now, in this case, the sysprep tool. So if we, as a developer, we were helping the ops guys out or we're helping people get the thing set up, we'll get the machine set up, it'll be patched, we'll get our software on there, whatever we need, whatever frameworks, all those kind of things. And then we'll run through the sysprep tool. And the sysprep tool is going to generalize that VM so that we can deploy multiple copies of it in the future if we want. Same technology we've been using on-prem for a long time. So a couple little features here. We'll make sure that we specify on the left side. You might see a test question about, what should we put these settings to whenever we're doing sysprep. And the thing you want to focus on is what I have on this slide. Make sure you put the out-of-the-box experience and generalize. Make sure the generalize is checked. That'll make sure that we rip out anything specific to that VM so that when we deploy another one, we're not dragging things along with it. The other thing to mention is make sure you set the shutdown option. So that's that combo box there on the bottom. Essentially what that's going to do is after it creates the image, it'll go ahead and power the VM down. So you can go do other things, come back, look at the portal, you'll see it shut down, you know you're ready to go. So you can specify whatever image name you want to use there. And as a description, it'll show up in the portal. You can see on the right side there what actually ends up getting generated out of that. It sits right alongside all the other images that Microsoft has up in the data center. So we have all of our standard workloads from the marketplace, and you'll see the My Images link at the bottom, and that points to whatever ones you've created. I mentioned DSC, or Desired State Configuration. This is a PowerShell utility that's now being used to manage state on VMs. Again, it struck me as a little odd that something like this might be covered on a developer exam, but you definitely need to know this for the 532. And essentially, we have a JSON file. It's written in JSON, and I'll walk through this, but you need to understand how to read these files. So if we said we have a configuration here called Contoso website, we're going to be passing a parameter in, which whatever the machine name is. We could put this in a loop and have it run over a bunch of machines. And then we have this node structure, which basically has different features in here. In this case, I have two things targeted here. I have an IIS role and an ASP.NET 4.5 framework. So pretty simple to read, right? So we can look down. We can see basically what's going to happen when this PowerShell command runs. It's going to say, is the IIS Windows feature, and it's going to say, ensure present. So it's going to say, is it installed? Is it running on this machine? If it's not, it's going to go ahead and do it for you. So it's going to lay down IIS for you. In the bottom case, actually, maybe I said, no, I don't want ASP.NET 4.5 on here. And you can see in that case, we said ensure equals absent. So it's going to make sure it's not there. So if somebody came along and, again, a test question just to frame it in that sense, the customer's looking to make sure that their VMs are consistent up there in Azure. And operations folks or developers have a tend to get up there and kind of monkey with some of the settings. This is a way for you to ensure that your configuration stays the way that it was designed to be. So we can set these things up, and essentially they run in a loop. So we'll just keep running these scripts against the VMs at a specified time, and it'll make sure our configuration stays the same. We got a question?
So is the pound install ASP.NET, is it a common? And should that be another feature there? Like should be a line?
Yeah, I'm sorry. Yeah, it looks like I'm missing the ASP.NET 4. I'm sorry about that. Somehow that got erased. But yeah, that's a good point. So basically those are comments, anything with a pound sign. So I don't know how that got erased when someone formatted my slides. Maybe they ripped my thing out. But yeah, there's supposed to be an ASP.NET 4.5 underneath there. That's correct. Thanks. The other way to kind of do the same thing that DSC does is this thing called the agent. So we didn't have this originally in Azure, and then we started coming up with it. And the original intent was around resetting passwords or helping the customer get access if they forgot the password into their VM. Because nobody has access to it. So we had this broker that we would basically install in a VM. And if anybody's ever installed or created an IaaS VM, you'll see the last screen when you're in the portal, when you're going to provision, it says install VM agent. That's what we're talking about here. So essentially it's a Windows service that sits out there that we can target with things. So we can tell that agent to go do things for us. In this case, maybe we're going to do some configuration stuff. So I have some stuff stored up in blob storage here, and it's a little bit of some code here in PowerShell. But essentially we have our file URLs here for two files. They're both in the storage account here. You can see it's a standard blob.core.windows. And these are PowerShell scripts. So you can see test 1, test 2, and they have some parameters they're going to pass to it. So in this case, we could run this PowerShell script at a scheduled time, whatever we need to run it at. We'll pass those file URLs in, and then we'll also give it a run line to tell it, go ahead and run the test one whenever you run this. We could also tell it to run multiple. We could say run file 2 and 3. And those can be totally custom. So if we have something maybe that doesn't work with DSC, DSC has a schema, obviously, for that file that I showed you that you can only do certain things with. But if you want to extend that beyond that, the agent's a great choice for that because we can use that to target other workloads. Again, test question around the customer has some custom scripts that they want to ensure their configuration stays, to keep their configuration in a certain state. You're going to be looking for the VM agent on that. Another thing that doesn't kind of fit in well, but we have to talk about it with virtual machines, is ACLs. So these things get locked down by default. So if we're spinning things up like SQL endpoints and those kind of things, we have to consider what Azure's doing behind the scenes when it's spinning these things up. So we can tie these to endpoints around our VM. So if we have a load balancer or if it's directly into the VM, we can tie the ACLs to either one of those. By default, we'll have to create these so that we can let people talk to these things. If you're using the PaaS type services, I know if you saw the SQL Server before, there's actually a checkbox there or a little slide thing now that says allow Azure services to access. And really, it's just allowing anything inside Azure to hit that thing from your subscription. This is a little bit more granular, so basically we can specify it down to say, only let this website talk to this database, or this website talk to this website kind of thing. Very simple to configure. Thing to remember, and these are great for test questions, is ordering is important. So you notice on here that we have like a permit and a deny, just like a typical firewall that we've had from the past. You got to make sure those things are in order. So if they give you a configuration and say it's not working, the customer's saying he can't access his database, and you see a deny that got snuck up above an allow, that's what you're going to be looking for. They usually show these as like ordering type things. Like they'll say, okay, so we want to make sure that this server can talk to this server, put these things in the right order, build the ACL for me. And then you'll have to drag those things over and do that. So from a management perspective, we basically have a couple different things that we can do with VMs. I took a little screenshot. There's a lot of things that we can handle on the management side, but the key things I wanted to point out here, which again are great test questions, are around the IP addresses. You'll tend to see things like, okay, so we're setting up a VM up here that's going to host a web service, and we're actually going to expose that to a customer, to another customer. And the customer is going to integrate with this. So we can't have the IP address changing, the public one, because maybe they have to open their firewall or something in order to hit this thing. So we want to make sure that if we're doing something like that, we have two concepts. We have reserved IP and we have static IPs. When you see the reserved IP, you're talking about the VIP and the public IP address, which is shown in there. So if we need to reserve that and make sure that that doesn't change, we'll want to make sure we do that. Now, by default, these things won't change because, if we take the VM down inside Azure, kind of back up a little bit from a resiliency standpoint, if you're standing VMs up in Azure, you've got to put them in availability sets in order to get the SLA, so you have to have at least 2 of them. Because at some point in time, Microsoft's going to have to patch the hypervisor that's running in that rack, and when that thing goes down, that VM's going down, so we need to make sure that we can keep your VM up. You have to have at least 2 of them in an availability set. When we do that, though, we're going to preserve the IP address. So just because Microsoft had to move your workload because of a hardware failure or because of a hypervisor update, it's not going to bring your application down, and we won't lose your IP address. But if you do have specific integration points, it's a great test question. Make sure you put a reserved IP on it so it never changes. There's limits to those again. There's a service limits page out on the Azure portal you should take a look at that lists all of these. There's tons of service limitations, and one of them is how many reserved IPs can you have. We also have, on the private side, we can do something similar, so we can do static IPs. So if we had an internal load balancer or we're communicating internally with these VMs, we can also tie static to that. So basically, you don't want to go into your VM and configure the IP address manually. That's going to break stuff. Eventually, you're going to lose access to that VM because you put something in there and we had to move the VM, and those settings will not save. So it's essentially a reserved IP. So you're telling Azure when you say, I want a static private IP, you're telling it to reserve the IP for this machine. So it'll always get the same one. That always happens to customers typically because they'll start spinning their machines down at night, maybe dev machines, and then when they bring them up in a different order, and all of a sudden things have different IP addresses and they're not talking anymore. So key point there, if you have a bunch of things that are communicating or a bunch of machines, you probably want to use static there. On the right side, we have this notion of web endpoint status. And what this is basically kind of like a ping that you can reach out to your websites. There's a thing in System Center that actually does the same thing. I think it's called GCM. And basically what happens is from all across the world, and you can set these up from ping points. You can see mine was from Chicago, San Jose, and San Antonio. You can have probes that are out there at those regions pinging your site. So if you had your site deployed in multiple regions, or maybe you just have it deployed in, like, let's say the East region, and you want to see how the traffic is or how the ping, like how much network speed latency we have from like the UK, we could set that up, and then we can tie alerts to that as well. So key question you might see on the test would be something like the customer's concerned about latency with their site that they have running on a VM, and they're interested in how can I make sure that that my site never takes more than 100 milliseconds to access. This is the tool that you're going to use for that, the web endpoint status monitoring. Again, you can tie alerts to these kind of things. They'll send emails automatically if you go outside the range, so you can specify the range that you need there. And the last one we'll jump into here from a workload perspective is cloud services, my favorite from the PaaS world. And we'll talk about a couple different things here. We'll talk about the design of a cloud service, like what's involved with it, what's underneath the covers, or what's running there. We'll talk about the configuration a little bit and some of the deployment models that we can use. And then we'll also talk about monitoring. So from a design perspective or from an infrastructure level, what's happening underneath the covers? So in the center, we have our cloud service. In this case, it's called KLT CS1. And that's our container that we're going to deploy our workloads to. So we can create multiple instances of web or worker roles in a cloud service. Now, that's all controlled by, we'll call this Mr. Developer over here on the right side. He has what's called a package, a CSP PKG there. You see that little box. So you can create those manually, but typically people use Visual Studio if you're doing this because it does it for you automatically. So if you click on the cloud service template inside Azure or inside Visual Studio, it's going to go ahead and create the CS package for you when you do your deployment. It's a zip file. So basically it takes everything that's inside of your site. So if you have your configuration, all your code, your binaries, everything that makes up your site, that's going to go in your CS package, and also 2 additional files. There'll be a CS config, a cloud service config, and a cloud service definition. And those are what's going to basically define to Azure how to run this workload. So we have our code, we know what the workload is. Now we got to tell Azure how many instances of this thing to run, what size of VM to run, what network is it connected to, certificates that are involved, anything that takes to run your site, like the environment, the infrastructure. And this is the key component that makes cloud services the attractive thing. So basically, once we have this little package built up, we can just take this thing and keep deploying it all over the place. Like we can spin up 10 instances of it and then crash it down to 2 if we need to. And Azure is going to take care of all the VM provisioning behind the scenes. So we can also, from a deployment perspective, we can do the things I talked about earlier. We can use continuous integration. We can use our web deploy. We can also use PowerShell to target these things. What's happening behind the scenes when you're using some of the web deploy models is it's just taking that CS package file, putting it in the storage count that's associated with your site, and it's going to, once it gets all uploaded up there, then it's going to take off and do the deployment from there. It never deploys directly from your workstation or whatever you have running down there. And that's what makes it nice for like scripts and things, because basically it's just a big bit bucket that we're going to move around, and once we have it where we need it, we can go ahead and tell Azure to execute whatever's inside of there, and it will go ahead and deploy it for us. We have our users on the right side. Not very interesting, but they're accessing whatever we have deployed. So I mentioned, and this is a definition file. As part of the configuration of our cloud service, we have a service definition. We'll walk through this a little bit. Important to understand some of these elements in here, and more importantly, what things you can set in here. You might see questions like that on the test, like, where do I specify the VM size for my machines, or allude to that fact with a question. And you're going to be saying, well, it's in your service configuration or service definition in this case. So we have a web role here that we have a named web role, and he's a VM size small. So that means he's going to be an A1. So we have the different SKUs out there. We have A0 through A9, and we have our bigger SKUs. But they correlate to extra small, small, medium, large, extra large. We can also specify bindings for our endpoints. They're going to be there by default. Obviously, we need to extend this thing so that somebody can access whatever service we're publishing here. And that's essentially setting up the load balancing and the endpoint exposure from our VM. In this case, we have an endpoint 1. And you can see then we have an endpoint section down here where we actually tie in a certificate and what port we're accessing there. Again, with the certificate, you'll see it gets in here. So these things can be created manually. So they could be, you could have your own tool set to generate these things. It's just straight up XML. Or you could use Visual Studio, and it has a nice little GUI in there for you to do all this kind of stuff. So if you go into the properties for a cloud service, you're going to see these things in there in a nice GUI format. You can tell which certificate to use, and you don't have to write all this stuff out by hand. Great way to learn what it is. There are features that you can't do that with. Virtual networks is a big one. So you might see a test question that a VM can't talk to an IaaS SQL server. So we've deployed the SQL workload, and now our cloud service can't talk to it. It's in a different cloud service. Well, obviously, we need to set up a virtual network here and get communications opened up. With a cloud service, if you go into that GUI I was talking about in Visual Studio, there's nothing in there about virtual networks. So you have to come in and manually edit your configuration in order to do those things. And that's documented on MSDN. But again, it's just important to understand that that's where the settings are that are going to control how this thing gets deployed to Azure, not your code. So the question was, would the virtual network be in the, this is the definition, it'll be in the actual configuration file, yeah.
So this is a collection of machines. How is this different from the resource group and the web hosting plan we talked about earlier?
So the question was, yeah, sure. So the question is, how is what I'm talking about here now different from like a resource group? This is when we're running a PaaS workload. This is specific to PaaS. When we're running a cloud service, this is going to control how the cloud service gets deployed. We can't just spin up a cloud service, like spin up a VM inside the cloud service. Azure is going to do that for us, and this is the way we tell Azure how to do that. So that's where it's a little bit different. So from a deployment standpoint, same stuff, right? Notice a little theme here, but we can do web deploy PowerShell and continuous integration. Key difference here around deployment slots. So I mentioned those with websites. We had 5 of them. They were user-defined. With cloud services, not user-defined. There's 2 of them, and they're locked by default. So when you go to do a deployment through like a publish inside Visual Studio, there's a little drop-down box that says, do you want to deploy this to the release slot, which would be our production slot, or do you want to deploy it to the staging slot? And essentially, that's going to control how we do our deployment. It's a key point to understand of how are we going to update our application once it's deployed up there. So we can do what I mentioned with the websites, where we can do a swap between the 2, which is essentially telling the load balancer to point to a different instance of the application. So we can do that. That'll work. There's no problems with that. We can also do what's called a rolling update. I don't know if you guys have heard, but we have if you have any experience with Azure, we have this notion of what's called domains inside of the stuff that we're running up in Azure. So we have upgrade domains and fault domains. Fault domains are there, and essentially there's 2 of them when you deploy a service. And what that's saying is, when I deploy my application up here, make sure we have to have at least 2 instances again for a cloud service because of redundancy, because we're going to patch that. But a fault domain is saying, make sure when you deploy these Azure that you put these in 2 different stamps. And stamps are like, think of it as 2 different racks, basically, inside the data center. So one single rack's not going to be able to bring my application down. Azure's going to maintain that for you. You can't set that. So you can't control that or anything. It's just going to happen mysteriously for you in the background. You can query it out of there, so you can get it from the API. You can actually see it in the old portal. You can see what fault domain they're in. The other one's upgrade domain. That's more interesting for us as developers. So upgrade domains are going to allow us to kind of walk the stack whenever we're ready to do an update. So if we come in and say, okay, I got a new version of my site here, I want to deploy this, but I don't want to deploy it just to, let's say I have 4 instances running up there. I don't want to just dump it out on 4 instances. I want it to do it systematically. Go do the first one, and then when that one's finished, do the second one, that one's finished, do the third one, and that one's finished, do the fourth one. In that way, we can handle that through these upgrade domains. So if we just simply do an upgrade, and when we give it our package, Azure will understand it and say, oh, it's an upgrade. I just need to go ahead and walk this. Incidentally, this is the same thing Microsoft does when they patch PaaS instances. So I mentioned before, when we have VMs, we have, the customer is responsible to patch the guest OS then, Windows. They have to keep track of patching and all that kind of stuff. With PaaS, Microsoft's going to maintain it for you. So if they come out with a security patch or an alert or those kind of things that we need to put on the server, they're going to automatically just target your machine and start doing it. That's why you have to have multiple instances up there. And what they're going to do is that same walking procedure. They're going to grab the first instance, they're going to pull it out of the VIP, essentially. They're going to patch it, bring it back up, make sure it's cool, put it back into VIP, go on to the next one, do the same thing until everything's patched. So essentially the customer sees one machine drop off, and you can see it in the operations logs when they do this kind of thing. Now, you can also control the guest OS. I don't think that level of details on the test, but you can actually tell Azure, don't patch my machines for a specified amount of time. Then you start getting emails saying, you're crazy, we need to patch this machine. Okay, so there is ways to do that. I don't think that kind of stuff's covered. But understand what an upgrade domain is. If you see it mentioned on the test, an upgrade domain is there to handle that walking procedure of updating one at a time, and what a fault domain is there. And it's a way for Azure to kind of make sure that we don't break the SLA with your application. So I keep mentioning web deploy, and if you're in Visual Studio when you're doing these deployments, you actually see this little activity log that pops up at the bottom when you're doing this as a developer, and you'll actually see the whole process go through. This is actually toward the latter part of it, so you can see the instance got ready, and then it was complete. But you'll actually see it before. It'll say uploading to storage account. You'll see that finish, and then it'll go on and say it's starting to install, and then it'll say it's allocating instances, and it's starting a VM, and you'll see the whole process go through there if you're watching that log. Great for diagnostics if you're having issues getting things deployed. Sometimes we mess up our configuration a little and things don't deploy correctly or we can't understand what's going on. This is a great place to dive into those details. The bottom part I have is a continuous integration section. So I mentioned before that little tile, remember where it had the continuous integration? I said if you click on it, you can set up the relationship to Visual Studio Online to do your automated deployments. So if you click on that, you actually see that box on the left side come up. And you can see it's going to visualstudio.com and whatever tenant you are. So if you provisioned your Visual Studio account ahead of time, you just punch in whatever the name of your instance is, and you'll hit authorize. So when you hit authorize, login window is going to come up and say, we need to verify your username and password for this VSO instance. You type those in. What's happening behind the scenes is a certificate's being created, and there's going to be encrypted communications that goes between these two now. So once that relationship has been established, you can set up continuous integration. And when you pop into that section later, if you get down to where it says set up deployment credentials, you'll actually see a list of deployment history. Great test question. So basically, every time you deploy, a new one's going to pop up there, and the active deployment will be at the top. But a good test question would be the customer says they want to use some sort of automated deployment, but they also, can they fail back on that? Is there any way for them to roll back on those kind of things? CI is the way to do that, right? So if we have CI set up, whenever we do a deployment, if I said, oh no, somebody pushed the wrong code, we need to pull that back. Hopefully it's a staging instance, not a production. We can just like right-click on that in the Azure instance and say revert, and it'll go to the last active deployment. So it'll do the revert for you. From a monitoring perspective, I mentioned before the operations logs. These are kind of the keys to understanding what's happening behind the scenes when we're deploying. So if mysterious things start happening to our configuration up there, things get moved around, things get renamed or something, and we don't know who's doing this. Azure's crazy. It's doing things to my VMs. This is where we can come in and look at those details. So every operation that happens up there is atomic, so it's a REST service. As long as it gets completed, we'll see the log up here. And in this case, if you read through this, it's basically talking about one of my instances. It did a update deployment status by slot. You can see it was doing a deployment update. So you can write tools around this, or you can come in ad hoc and do look at your logs to whatever's going through there. I mentioned before that we had those workloads, and then two other things that kind of tie into there, one of them being storage. So storage is an interesting thing because it's encompassing all of our different workloads. These are definitely things you need to know for the test. We need to know how all these things kind of fit together. But basically, we have Azure Blobs and Azure Files, two different things that kind of work similar, but we'll talk about the differences. We'll talk about Azure Tables, NoSQL type database. We'll talk about Azure Storage Queues and how they kind of differ from a Service Bus queue, two different technologies. We'll talk about access control. How do we get access to these things that we deploy in storage, monitoring, and then we'll talk about some of our PaaS SQL database options. So for the blob storage, we basically have on the left side, we'll talk about that first. So again, we're in the container mode here. So we have our storage account. You can see it's KLT.str. Inside of there, we have to create a container. We can't store blobs directly in Azure Storage Account. Might be a great test question, but you can basically create as unlimited containers that we need up here. We create the containers. Think of it as a folder, and that's where we're going to store our blobs. We can tie policies to those, and that's where the SAS token option is coming underneath there. A couple slides later, we'll walk through exactly what that SAS token is about, but that's a shared access signature, and that's a way we control access to blob storage. Two different types of blobs that are up there. We have block blobs and page blobs. They target two different kinds of workloads. So block blobs are really about, so if we're going to upload data or if we're going to change it and we want to swap out individual blocks, we can specify exactly which block. So if we had a terabyte of data up there, we can specify just go to this offset inside of there and replace these 10 bits kind of thing. Works great for that kind of thing as well as if we're doing uploads, so we can do resumes because it basically, if we were uploading a gig file and we get halfway through, we know what block we're at. We have an index in there and we can just resume from that point forward. Page blobs are streams. So think of them like in .NET, we have the stream class. You can't index in directly into a stream. You just have a stream, and you have to play through that stream. That's what a page blob is. So as we add more data to it, it just gets appended to the end of it. We can't replace individual sections of it. Page blobs are usually used for like BHDs. That's the workload that usually comes there. Block blobs are more for application level, if we're writing an application that we want to store image data, those kind of things up in Azure. Typically, something like block blobs are what we're going to use. With Azure Files, a little bit different. So it sits on top of blob storage. So again, we have our storage account. And what we do is we're able to create shares in there now. So essentially what it's doing is it's carving out some blob storage, and it's putting an SMB layer on top of that so that we can expose it just like a Windows share. It has a couple little differences. So when you establish a connection with that, so let's say a typical workload for this, again, might be a question, but is what would we use Azure Files for? We can't expose them to the internet. We can't expose an SMB share to the internet. But what we can do is that one work case would be a dev test environment. So we have a bunch of developers. They have VMs up there, and they need a place to share their files for all their stuff. Instead of firing another VM up, we can just establish a dev share up there and have them dump their tools up into there. And all the VMs can then just hit that file share to get their stuff. It's also good for like lift and shift type applications. So if somebody's doing a migration and they don't want to make any code changes, or they want to make minimal code changes, and let's say it ties out to configuration files or things on the file system, this is a great model for that because it can use the UNC path model. Typically, old applications can use that. Key thing to remember is they can be accessed two ways, these files. They can be accessed through SMB, like I've been talking about, but they can also be accessed through the REST interface. And that's how you can get access to these things through the public internet. So the SMB share is not shared on the internet. The REST share can be. A couple stats here about these things. It's good to read through these things because you might see stuff like around the size. You could see test questions around that saying they want to store, let's say they wanted to store 100 terabytes and they're thinking about using Azure Files. That's going to be a problem, right? Because we have a limit there. And they're pretty extreme. It's from like 500 terabytes to 5 terabytes. So just knowing, at least a little bit around where those are is probably a good thing. Also, the upload speed is much different. So we can do 60 meg per blob, but it's per share on the throughput on a file share. So a little bit slower access typically, especially if we're uploading multiple things. You can read through these. The URLs are slightly different. They have the file in them instead of the blob. One key thing about the Azure blobs is you can't create folders up there. So I mentioned containers. You can't create directories up there in those. They have a way to do that, which is essentially kind of like what Unix does, but basically we have we can regex the path, and if it has slashes in there, we consider it to be a directory. There's an API around it that says directory, but it's not really a directory. It's kind of faking it. It's all flat. With the Azure Files, it's actually true directory objects. We can create the same stuff that we can in Windows. That's why it makes it great for lift and shift, because it's not special. The stuff in blob storage is kind of like almost always requires coding in order to do it. So, sorry? Question?
The files contain metadata?
What's that?
Can the files contain metadata as the blobs can?
So the question was, can the Azure Files, contain metadata similar to the way blobs do? It's different. So it can contain the same extensions that we have in Windows. So all the properties and extended properties that we have in NTFS file system, those things can be there, but there's no additional metadata like we have with blob storage. Good question. So another sample storage question here. This one is a customer is interested in using Azure Blob Store to store images for a social networking site, and they're new to Azure, but they've set up their account and their subscription. What are the steps to store these images if they're looking at their app and saying, I just want to store these up there? And essentially what you can do is walk through this, but we would create a new storage account would be our first thing, right? So we would go ahead and create the storage account. We would create a container that we're going to put that in. He's kind of just in there to throw you off, but he's nothing. You can't set geo-replication for a storage container. You can only set geo-replication for an account. So we would create our account, create our container, and then we could update our application to use our storage library. B is also one just to throw you off, but there is no metadata XML file with that in there. So essentially, I'm just trying to get home the point that you have to establish the storage account and a container, and then you can start using it, the API in your application, the storage client API. Storage tables, slightly different concept, similar. So we basically have our storage account again, and now instead of having a container, we have a table. So we just name these tables whatever we want, then we store entities in there. Key point to remember is, where do we use tables? Why would we use them? So these entities can just be, bags of properties that we have about something. An object, let's say it's a customer object that has a first name, last name, email address. We can basically create that entity, and we'll just save it into Azure Blob Storage, and it gets persisted there. Now, there's a lot more to it than that, right? So we have to consider things like, how are we going to query this thing? So key point to remember is, if a customer says they really only need to query by these certain things, like they need to query by the customer name or by the location or something like this. If you're seeing a singular key there, great target for Azure Storage, Azure Table Storage. If you see more than one, like they need to query it different ways, this is not a great storage story here. In those cases, what we have to do with NoSQL is actually store it multiple times in different ways so that we can get that query performance. We can't do things like joins in here without jumping through crazy hoops and really slowing the process down. So it's not ideal for that kind of thing. If you see complex relational data that we need to store and we're trying to shoehorn it into tables, it's not really a good fit for that. What it does do well is scale. So if we can get our queries matched down to exactly what we need to store in there, we can use something like table storage. We have what's called a partition key and a row key with every entity that we store up there, and that's what forms the primary key. So those things have to be unique. The partition key will basically say, here's the storage stamp that we're going to store this in, and the row key is going to be the index into that row, essentially. So those two form the primary key. It's exposed through OData, so you can expose your data as an OData type client. So if you have clients that can access, that are OData aware, they can access the table through that. We also have table clients for all the latest stuff, Node.js, .NET, of course, Java, all the different ones. And queues kind of follow the same model. So with queues, we actually have our storage account, we create a queue, and then we have messages inside of it. Now, we have a queue client that we can interface with this thing. We can use REST-based interface always as well, too. And essentially, it's a very simple message queue. So it's like we used MSMQ in the past. This is a great model that follows something similar to that. There's some key differences between Service Bus queue, and it pertains to the message sizes. These can store slightly larger sizes. Yeah, it's kind of a misnomer about the message size, because typically, if you don't want to store large messages in message buses. You want to store pointers to those things that they are. So if you had a large message you want to store, let's say it has a blob storage with it, put it out in blob storage, get the URI back, and put that in your message. Makes your messages much smaller. They scale much better. But again, this is just a way to help disconnect the different tiers of your application. So if you saw a test question where they said they want to make sure that the thing can scale well, this is one of the key tenets to making things scale well. We don't want to tie some process that has to run to every request that comes into the web server. Eventually, it's going to run out of horsepower and can't do that. If we could offload that and just post a message to a queue and then have a worker row or something come along and pick that up and do whatever back-end processing we need, then the request queue is clean and can keep scaling and adding users to it. So great model for kind of decoupling your application, and great model for the cloud. And you notice with all the ones I showed you, the blob storage, the queue, and the tables, we had this access control, and this is kind of walking you through a little bit of how that works. Now, what we have here at the bottom, we have our Azure storage, our cloud over here, and we have our core application, which may or may not be running in Azure. And then we have this other component called the SaaS token service. The SaaS token service is something that you can build. Typically, it's hosted in Azure, but it doesn't need to be. There's no requirement for it. All its job is to do is to say, if somebody gives me a request and they're a valid user, so typically we'll wrap some sort of authentication around that, Azure AD or something homegrown. But we have a token service, so our application is going to say, I need to access some blob storage. Before he can do it, he needs to get a token. So the token will come from this token service. He's going to send a request to the token service. Again, you handcraft this, so it could be a web API call, MVC type application. This thing's it's very simple. There's about 3 lines of code. You can basically tie it to whatever it is. If it's a blob storage, if it's a queue or a table, there's an API in our SDK that basically generates a token for you. You specify how long you want the token to last. That token gets generated, given back to the application. Every time he makes a request, he gives that token to blob storage, and blob storage knows it's okay. This is one model. This is a great model if you need to expose the blob storage publicly. Sometimes we like to put our application in front of the blob storage. That's another way to do it. But that tends to not scale as well because now the clients have to go through another layer to get to whatever that thing was. And if it's a static image or something of that nature, it could slow the request down, ultimately the scalability. So this is a great model to do that. The only other way we could do that is to give the client the keys, which we don't want to do. We have a lot of clients out here. We don't trust them. We don't want to give them our storage keys. This is a way to give them a key that only works for a little bit of time. We can also tie policies to this. So the policies would be like read, write, list. If it's a container, you can list the objects in there. So we have some granular access for how we can control that. Again, those would be great test questions, but how do you control access to these core native components of Azure? SaaS and a SaaS token service is really where it's at. And the last thing here with storage is around monitoring. By default, there are limits, again, like I mentioned, and you can hit those. If you have something that's really active up there and keeps hitting blob storage, there are limits to how quickly you can access, read, and write data to blob storage. And if you hit those limits, you will be throttled. And so 2 things to consider with that. One is you can set up some alerts and some monitoring in here by enabling these things, which, again, are off by default. So you enable whatever features you want to have in here, like the blob aggregate or table aggregate. So if you're just using blob storage, maybe you want to turn on the metrics for blobs. And that will start to surface that then through the portal, and then you can expose it back to your backend systems to be able to put some monitors around, making sure we don't hit this threshold. The other thing to do is just in your code, make sure that you're writing things for fault, the transient fault errors is really the model to use there. And really what that's about is, if I'm accessing something in the cloud from my application, let's say blob storage, I have everything set up, but we can't 100% rely that every time that request is going to complete. So in order to handle that, basically we say if we get back and say it timed out, we couldn't access it, something happened there, basically we do a back-off model where it says, okay, so wait 10 seconds and try it again. Okay, it didn't happen again. Wait 30 seconds. And you do this exponential back-off until you hit your threshold of saying, okay, we just need to give up. Something's wrong. Throw an exception, and then we can alert it through our monitoring systems. But it's important because not every single transaction that you ever write to blob storage will complete successfully. It's just the nature of the cloud and the internet. And the storage, the last one around relational database, is SQL Server. So this is our PaaS SQL Server model, not the IaaS. So the IaaS is you just run an IaaS VM, you put SQL Server in it. This is the PaaS model where it's more of a multi-tenant model. Key things to remember are there are different SKUs there, right? We have our basic, standard, and premium. And it's really, the next slide will show you a little bit more detail on this, but it's really around how many transactions we can do, how many number of operations and users we can accommodate with the SQL Server. So just having a general sense for these kind of things, I'll pop over to here because this probably explains it a little better. But we basically have our transaction rates here. Again, it's not necessary to memorize each individual one, but have a general sense for where they kind of line up and where they differ. So if we have something that's like in a basic SKU and we're trying to do a large number of sessions, it's probably not going to work out. So if you see a test question saying that they need to support 10,000 users, you're not going to be using a basic SKU because there's no way it's going to be possible to do that. So the last thing is around network and management. And so in these are kind of the other things that go along with your application. So we've been mentioning Azure AD along the way and how that might work from an authentication standpoint. We talked a little bit about VNets. We'll talk a little more here. Our VNet configs, how the communication happens between things in the cloud. Some of our monitoring and caching options that we have. So from a network, and let's talk about Azure AD for a second, some of the differences. Again, this feels a little infrastructure-y, but you need to know this as a dev, especially around authentication and authorization frameworks that you're using. So if we look at the bottom first, the on-premises world, we have Active Directory, and we have our different workloads we have out there, Exchange, SharePoint. Key thing about Active Directory, though, we have LDAP, right? It's an X500 directory service, and we might have some line of business applications. If you look at the top, similar model, right? We have Exchange Online, SharePoint Online, but we have this Graph API. Important to understand what Graph API is. So Azure AD does not expose an LDAP interface. So if we have an application that has a dependency on LDAP or it has hard-coded in to use LDAP, that's going to have to change if we're going to leverage Azure AD. And Graph is what's going to fill that in. And Graph is it's an OData service that sits in front of Azure Active Directory. So we access it just like a web service through OData. There's actually a tool out there for developers that's great. It's called Graph Explorer. So if you go to graphexplorer.cloudapp.net, if you just look it up, you'll see. But it's an application Microsoft put up there to help developers as they're getting started. And you can basically log in with your credentials to whatever your Azure Active Directory domain is, and then you can enumerate things. You can run OData queries against it and see what your results are. So great little test harness while you're building applications and leveraging Graph API. From a network standpoint, the things you need to know for the exam are really around how do we do hybrid networking. So there's different things to accommodate the hybrid networking model. On the left side, we have our on-premises network, so we have a bunch of servers deployed there. Right side, we have our Azure network with a bunch of VMs, in this case, deployed and different subnets and that kind of thing. So the key thing to understand is there's multiple ways we can get that connection going. My line doesn't show in the middle there. I think it got blurred out. But essentially what we have is we establish gateways on both sides, and that's what those two VPN things are showing. So we'll set up our VPN, or we'll set up our virtual networks over here. And obviously we have a network established already on-premises, and we'll go into the portal and say we want to go ahead and provision this, and which will establish the right side gateway. When it establishes that right side gateway, it's essentially a PaaS instance that's going to create. It's going to create two of them that's running RAS. And those are going to get deployed for you automatically. You just tell it, I want to use a site-to-site VPN. You set up your keys to use your device. So usually it's a device on the other side. It could be 2012 RAS as well. We could just run software-based over there. Or we can use a hardware appliance like Cisco or any of the popular ones from Checkpoint, those kind of things. Key thing to remember is just that we have this site-to-site capability. From a developer standpoint, it's not an infrastructure thing. It's just how do we get that connectivity established. And we also have this private mode, which is the express route. So that little enterprise thing up there at the top. Express route is a little bit different from VPN. It's a private connection, so it's essentially like a lease line that you would establish with a carrier like Verizon or Level 3 or any of those guys. And essentially, it doesn't go over the internet, so it's not a IPsec tunnel over the internet. It's actually a private connection. Much higher speeds, much more expensive, but you can go up to 10 gig with that. So the latency is much, much better. Key things to remember is if you see stuff around a scenario that they're presenting with you on the test and saying that they need 1 gigabit connection, they need high-speed connectivity, you're going to be in express route territory. There's no way to do that with the VPN. VPN has two models, standard and high performance. That's 100 meg and 200 meg, and that's maximum that's theoretical throughput. It's actually a little lower because it's going over the internet, and you have the overhead of the IPsec tunnel. So it's really something like 80 and probably a little under 200 to do that. When you're setting up your VNet, basically you're establishing different subnets. This is pretty basic, and this is what's expected from a developer sense of understanding what's involved with VNet configurations. Essentially, we establish a address space, and then inside of that address space, we can cut it up into subnets. Very simple. We're going to use those names. There's significance to those names. So the name of the actual VNet you'll have to give when you create it, as well as the subnets. And when you specify that in the configuration files, like I was telling you earlier, you'll be using those values. So in this case, it's the arbitrary stuff of subnet 1 and 2, but you could name those like production, web 1, things like that. But that's what you would use to reference them. Sure. Question? So the question was, is there routing between the networks? If you deploy things in the same virtual network, even if they're in separate subnets, they can communicate through there. If you want to control access to that, that's a little bit different story. In that case, you probably want to set up multiple VNets, and then you control how those things communicate, so you can keep them totally isolated. But if you just create a separate subnet for like DB, and you're thinking, I'm going to keep that isolated that way, not by default. Anything that's in any of those subnets is going to be able to see that thing.
So each VNet is acting like its own VLAN?
Yeah, exactly. Now, there's some stuff that's just been announced, literally like yesterday. So if you look at the vlogs, there's some things that have been announced to control routing between these things now, so we can do some of that stuff. It's great for those virtual appliances, so Barracuda, Checkpoint, some of those guys, they have VM images that are up there in the cloud that you can use. Customers like to sit those between subnets so that they can filter and log all the traffic going between there. With this new feature that allows us to use user-defined routing, it's going to make those things much more effective. That was a big sticking point before. We didn't have that. So network, from a service bus perspective, it does a lot of things, right? A little bit of a Swiss Army knife here, but basically it'll establish queues, so we can do our FIFO queues, very simple client to access that. I mentioned there's some limitations around message size, those kind of things, but really a nice enterprise level service bus, or message bus. Topics are another level. So basically topics allow you to basically target messaging to specific clients. So if you have listeners that say, we're going to use this message bus for a bunch of different things. We're going to use it for the log-on messages that come in. We're also going to use it for this back-end process that I'm running. So we have multiple different workloads, and we're leveraging the same namespace. We can do that with topics. So we can basically set up a topic, and all the messages will go to that topic. The listener attached to that topic receives those messages through whatever means he's using. But you can basically partition it a little bit better that way. And then we have a relay option, which is basically, this has been there since the start. This used to be the way we did hybrid connectivity for web services. So it still works today, but basically if we have a WCF service that's running on-prem, we got a question?
Yeah. On the topics, would it be a web job to receive the topic messages? Or how would the message flow from a topic to another service?
Sure. So the question is there a web job or anything associated to receive the message? So basically what happens is you have a sender and a receiver when you write these things. You write a little wrapper for it. So whatever thing is sending it will have a little wrapper around how it posts the message into there and what topic it's going to post it to. On the other side, you basically, whatever web server or backend server that you want to do it, it will implement the service bus client as well. And in its configuration, when it fires up, it'll also, you'll put the topic in there as one of your configuration values, and that's how he knows to read it. But it's custom code. It's whatever you want to have run on the other side. If it's a Windows service, it could be that. It could be a worker role up in the cloud. It could be an executable, those kind of things. You could actually have a web job actually reach into one of these queues if you wanted. Back to the relay. So the relay was there to basically say, I have this WCF service on-prem, and I have my application up in the cloud, and I want these two to talk, but I don't want to set up a VPN. So what this would do is there's a special WCF config that you can use for this, and it will attach, it itself will reach out to Azure, make a connection, then it will hold that connection open. Once the connection's open as a TCP/IP connection, the stuff up in the cloud can then just start talking to that service. And that's the way that worked. Azure Connect, if any of you have been around since Azure started, we used to have a tool called Azure Connect. It did something very similar. It was an agent that you could put on your VMs. We don't use it anymore. But the big thing is it could go through firewalls. So you don't have to open any firewalls because it's an outbound connection, and typically those aren't blocked. Notification hubs is the last thing, and it's around mostly around mobile. So basically, Microsoft has created this thing called a notification hub where it allows you to forget about what the client is. So these things are around these toast messages or these posts that come out on different platforms. We don't want to have to write something for Android and Apple and Windows because they're all different formats. So in this case, we could actually establish a notification hub which rides on top of Service Bus. We could post the messages into there, and then you tell it in the metadata for that which one you want to target, and it will broadcast those out to whoever. So if you wanted to target Apple and Google, Android phones, as well as Windows, it will do all that translation for you to make sure that it is formatted correctly. Code question, these are pretty typical in the test, especially on the developer exam. So you get stuff like fill in the blank, and then you have options listed on the right side. So in this case, we would have our connection string. Obviously, we would be using the top one, so Cloud Configuration Manager. We're going to get our connection string out of there. Then we would come down and it's saying, okay, so we want to create a namespace manager, create it from a connection string. We're going to reference our connection string, obviously, so that would be F for the second one. And then the next thing with a queue would be, okay, so we need to test if the queue exists. So we'd be using something like E. So we'll check if the queue exists, and we'll give the name of the queue. And then the last one would be C, obviously, for creating the queue. Again, it's not, I mean, you can go through these whenever you want, but this is the kind of example of a test question that you get, especially on a developer exam. Again, I've been mentioning it all along, but there's the ways to access Azure is through the portal, PowerShell, or REST API. Everything in the portal comes through the REST API. So just keep that in mind. I mean, basically, if you have access to this last one, the REST API, which you do as a service management API, you can do everything, probably plus more, what the portal can do, because they can't keep the UI stuff up as fast as they can create new services on the back end. Just important to remember that you can use any of these to access those. I think this is the last topic, but basically caching. Sorry, we're running over just slightly here, but it's a lot of content. But the caching, a couple different stories here. We had the manage cache on the left side. That's basically App Fabric. which has now been given an end of life of April 4th or April 7th of next year. So if you have customers using that, you probably want to start thinking about what the next step is. So that was a model that we had, and it was a PaaS service. So you could just come up and say, I want 128 gig of RAM up here, basically, and I'm going to use that as cache. Those things are being migrated into Redis Cache. That's the new service offering in Azure from a PaaS perspective. Cache as a service. Redis offers the same stuff that we did with App Fabric and a key value pair store kind of thing for a cache, but it also does more. So I have advanced key value store. You can actually store structures up there, which is one of the key components for Redis and why you would want to use it. So if you saw a test question saying, the customer wants to store and wants rapid access to these, or there's some configuration values or values that don't change very often, when you see those things, those are hinting you toward cache. You can store structures in Redis Cache, so no problem there. The last thing is the enroll cache, and that's basically with our cloud services. So we mentioned web and worker role. We can actually take one of those worker roles and use what's called co-located. I have dedicated and co-located. Co-located means I can actually carve out a piece of the memory of that VM and say I want to use this as cache. You wrap a name around it, and then you can initialize into it and use it as a key value store. Dedicated is exactly what it means. We take our worker role and we dedicate everything that has memory to a cache server. So that's another way. Good for lift and shift apps. Again, you're controlling all that, so it's basically you're running it in a cloud service. With the Redis Cache model, you're hands off. It's kind of like a PaaS service. You're just saying, I'm just going to make calls into this big cache service, and it's going to do my thing for me. So just to review, we went through websites, virtual machines, cloud services, storage, and networking, and other things. And I'm hoping that I hit on some things that help you better prepare you for the exam. If there's some things, if you have any other questions or anything, this is very hard to cover all this content in this time, but just reach out to me. I'm around here all week. I'll be over at the MCT stuff. If there's any specific questions you have about it, just let me know. We also have some other resources out here for the learning site, our virtual academy. I've actually done a bunch of those up there. There's some stuff on 532 where they cover it a little bit more in depth because we take an hour for each one of those things to talk about it. And then we mentioned the CERT app. And that is all. Thank you.